Hello, welcome to Stat 108, and here I've got our My Open Math page up just to show you where you can find this video and other tools. So here's our calendar, and you can see some of the upcoming assignments, and right here I've got a link to the video that you'll see in the future, and you can follow that link. Another location where you can find this is within the experience folders, and right now it is not populated because I'm making the video right now, but I will have links to them here. Sometimes there are multiple videos for an experience, so you'll be able to find a list there. Okay, and for this first week of material and topics, we're going to go over this PowerPoint presentation, which has a lot of foundational material as an introduction for statistics. So I'm going to open that right now. Why are statistics important in our life? Well, a lot of information that we consume on a day-to-day basis is driven by data and statistical analysis. So as an introduction here, I think a lot of us probably see and have an intuitive understanding of some statistics that are displayed to us in everyday life. For instance, weather. Weather is forecasted based on very intense statistical and mathematical models where data, information based on current variables such as pressure, wind, temperature, etc., where that information is used to learn about something in the future, right, to make predictions. And furthermore, here's another example of statistics based on weather, where information is displayed in a certain type of graph. This is called a bar graph. We'll eventually go over that. And you can convey a lot of information really quick. For instance, which type of phenomenon here seems to have maybe the largest number of fatalities? Well, this red graph, this red bar over here for flood seems to stick out, right? So some information is being conveyed there pretty quickly. Heat also seems to be another phenomenon that has a lot of fatalities associated with it. So even without taking a statistics class, I assume that your average individual could see an image like this and be able to interpret it reasonably well. Another topic that is riddled with statistics is the health field, and especially health and related with fatalities. And here, another basic graph, but it conveys a lot of information really quick. And certainly if prescriptions or medication is administered in relation to some of these ailments before any drug is prescribed, those types of drugs need to be tested and their efficacy needs to be verified, and a lot of statistics is going to play a role into that. Lastly, my last example here, I don't know anything about this, but if you are a sports fan, certainly everything about sports has been dissected in terms of stats for teams and players and different variables associated with each of those. A common facet of statistics is trying to find patterns or trends in information that's been gathered about something that you care about. And those patterns or trends aren't necessarily given in black and white, where those patterns and trends, if they exist, are sort of muddied or muddled with a lot of other information and needs to be dissected to be understood. And so I kind of like this graph, this little figure, but it's a little interesting as well, where there might be a signal, some decreasing trend, for instance, but that signal might be hard to visualize because it is obscured by other noise, and these are technical terms. And so data that is observed may not be so clear. What is that trend? Because there's a lot of other information that needs to be sifted through. All right, we are going to start with the first chapter or first experience associated with our textbook, in which we're going to establish a lot of terminology and foundational topics for the discipline of statistics. Let's get going. Generally, statistics is going to rear its head when you are researching a population. And there's something particular or things that are particular that you're interested in that population, where the population is everyone or everything that your question applies to. Now, generally you don't have access to an entire population. Maybe you want to study humpback whales and their migration patterns. Well, you're not going to be able to observe every single humpback whale in existence, but you may be able to monitor a sample of humpback whales. So a sample is a subset of the population that is available for study or selected to study. Once you have a sample, then you would collect data or information from the individuals or the observational units in your sample. So data is often considered plural, and a datum is a single observation. Sometimes I misspeak, but I'm a human as well. So this whole process, research question, developing your population, collecting info from a sample, this all is embodied in the discipline of statistics, where you are collecting, designing studies, organizing data so that it can be analyzed and presented. Descriptive statistics is generally a summary of data, where you are summarizing a lot of info in a brief statement or statements. Inferential statistics is taking those descriptive statistics and drawing conclusions about the future, or drawing conclusions beyond the sample based on what was previously observed. And we'll talk about more of that in the future. Let's look at some brief examples of descriptive statistics. Here's a graph. You've probably seen a figure that looks something like this before. You might even already know its name. That circular shape, this is called a pie chart. And a lot of information is displayed really quickly in this pie chart. We can also display this same information in a different type of image, such as this type of figure. This is a bar chart, but it is displaying the same info, just in a different way. If I were to ask you a question, could you analyze these images and report the answer? What proportion of students identify as Hispanic? Well, if I look at the pie chart here, light yellow, about 17.1%. But I could have also done that over here with this bar chart. Let's look at another example. Okay, what we got here is another type of image. It looks kind of like that bar chart, but there is some differences, and we're going to discuss those in more detail in the future. But let's see, we've got the number of credit hours completed per student. So it looks like there was lots of students sampled here, and we've got some number of credits achieved. It looks like it varies from about 10 all the way up to 25. And I could ask you a different kind of question about this information. What is the average number of units these students completed? Now, we can't really calculate that with this information, but you can probably estimate it just from this graph. It's probably somewhere between 16 and 19, maybe. What would the data look like that accompanies this image? Well, it would be a list of numbers, right? And then they are all composed into this image. So a whole lot of information is condensed into this image, and that's what these descriptive statistics do. They summarize a whole lip of info really quickly. I want to make a distinction between this slide and the previous slide. So if this is what the data look like for the number of credit hours, right, those are all numerical. But in the previous slide, here these are qualities about individuals, right? Those are not numeric. So that's a very different type of data. And we're going to discuss those intricacies in the near future. But now let's look at an example. And of course, cats on YouTube. Probably the reason why YouTube exists is for cats. So let's look at a scenario here and dissect elements in this scenario. Suppose you want to estimate the percentage of videos on YouTube that are cat videos. Of course, it's impossible for you to watch all the videos on YouTube, so you're going to use a random video picker to select 1,000 videos for you. You find that 2% of these videos are cat videos. Okay, what we're going to do is dissect this little scenario to identify elements of it as either a datum or observation. I like observation better. A sample statistic, or a population. All the videos on YouTube. Well, we know we can't watch all the videos on YouTube, but that is what this study is pertaining to. So all videos on YouTube, that must be the population. Next, 2%. Where is this 2%? What does that relate to? Well, that was relating to the 1,000 videos. The 1,000 videos were the sample. So this is a statistic of that sample. A sample statistic. We'll talk more about those in the future. Next, part C, the 1,000 videos selected at random. Well, that is the portion of the population. So that's going to be the sample. And lastly, whether or not a video is a cat video. Well, by process of elimination, you probably know the answer, but upon viewing these videos in the sample, what is being observed? Basically, cat or no cat. So those are the possible data values. Those are the observations. So what would this data look like? It's probably just a list. Cat, no cat, no cat, no cat, no cat, cat. So that's what that information would look like. The next several minutes are going to be dedicated to discussing variables. And variables are elements or characteristics about a population that you want to study. And I've already shown you a couple variables already with the race or ethnicity and with the number of credit hours. So with the number of credit hours, those are values, but we could also have a variable that is a category or a quality. So we have this little tree that I like to use. A variable can be either quantitative or, you know, the opposite of quantitative, it's qualitative. I often say categorical, but we can use those two terms interchangeably. But these qualitative or quantitative variables can also be further distinguished. A quantitative variable is either continuous or discrete, and a categorical variable is either nominal or ordinal. Let's describe these in more detail. A continuous quantitative variable is typically a variable that is measured, and it can take on decimal values. So if you can half something, like half an inch, half a kilogram, it is probably continuous. Whereas discrete quantitative variables are whole numbers. So those are variables that are countable, like the number of people in a room. Another example of a discrete quantitative variable could be number of psychology majors or number of seniors. So when a variable is counted and can only have whole numbers, that is a discrete quantitative variable. On the other side, let's look at categorical variables now. An ordinal categorical variable. Categorical or qualitative variables have attributes or qualities, and sometimes those attributes can have a natural ordering to them. In that case, those categories would be from an ordinal qualitative variable. So order, ordinal, that might be like a medal, an Olympic medal. There's bronze, silver, gold. There's that natural order to those categories. On the other side of this tree here, we have nominal categorical variables. And that is when the categories in the variable are qualities, but they don't really have any inherent order to them. So if you have a list of majors at HSU, there's not really any particular way to arrange that list of majors. And so the majors would compose a nominal categorical variable. A common theme that we're going to see in our class is that the type of data or variable that is of interest determines the type of analysis that you can do. For instance, as we showed with the pie chart and the bar chart earlier, if you have a categorical or qualitative variable, you may be able to say the proportion of seniors in a class or the proportion of psychology majors in a college, but you're not going to be able to take the average of a list of majors. However, if you have a quantitative variable, you can report the average because they are numeric. You can add them up and divide, and you can do other arithmetic with them. So whether you have a qualitative or quantitative variable will determine what kind of analysis you can do. So it's a very important fundamental topic. Now we're going to spend some time looking at examples. I'm going to display here the variable, and then right below it are the values or the categories that compose that variable. All right, fishes in the Snake River. We've got different kinds of trout here. That appears to be categorical. Furthermore, there's no inherent order to these trout, and so this would be a nominal categorical variable. What about this one? Teacher rating. Unacceptable, poor, fair, good, excellent. Here we have another variable, and it is composed of categories. So yes, it's categorical, but in this case, it appears that the categories have a natural order to them. So that would be an ordinal categorical variable. What about this? What if we had teacher rating yet again, but instead of unacceptable, poor, fair, good, excellent, we have 1, 2, 3, 4, 5. Now this one's kind of tricky because you might see these numbers and think, oh, quantitative. But this is actually still categorical because these numbers are not necessarily measured and they are not necessarily counted. These are values, yes, but they are representing an idea, a category, and they were not measured or counted. So tricky, even though you see numbers, it does not necessarily imply that those numbers compose a quantitative variable. Let's look at another one. Number of eggs in a bird's nest. Alrighty, all right. So this is number of, so these are being counted. So that's a quantitative variable that is discrete. Next, flow rate in cubic feet per second of the Smith River. A beautiful river up here in Northern California. Now this is flow rate, and this is a measurement, cubic feet per second. So that is quantitative, and because it's measured and you can have half of a cubic foot, that is a continuous quantitative variable. Got a few more for you. Number of cancerous lymph nodes in a patient. You're counting them up, so that's a discrete quantitative variable. What about US Army rankings? I know I'm missing a few here, but I think these are some of the major rankings. There appears to be some order to those, right? So that's an ordinal categorical variable. What about blood type of a person? Well, that would be categories, right? So is there a particular order to them? Not necessarily. You can shuffle them up and it's just a list of blood types. So that would be a nominal categorical variable. Now that we've discussed variables, we're going to cruise back to discussing populations and samples and talk about some distinctions to be made between those two entities. Research questions pertain to a population, and we would like to learn about that population. And certain qualities that pertain to the population are called parameters. There are quite a few different parameters out there. We generally denote them with Greek letters, so we'll learn a little bit of the Greek alphabet in our class. Two parameters in particular, one is called the average, and the other is the standard deviation. We're going to spend a lot of time on these topics, but these are just examples of population parameters. And you probably already know what the average is, but for it to be a parameter, that would have to be an average that pertains to an entire population. Let's look at an example to illustrate a population parameter. So this is called the Greek letter mu, and mu may represent the average weight of the stellar sea lion pup population off the north coast of California. Okay, can you actually determine the weights of the entire pup population? Absolutely not, right? That's an unattainable task. But your research is interested in this population, and you would love to know the average weight of all the pups, but you're not going to be capable of doing so. Therefore, a population parameter, it represents a population level idea and is usually not a tangible value that you can calculate. There are exceptions to this, but in general, we are not capable of calculating population parameters. To learn about a population, we generally collect a sample from it. Information that is collected from the sample are called statistics. And we shorthand these not with Greek letters, but with regular letters that sometimes have hats on them or bars. And these are two letters that are often used to represent the same idea, the average or the mean and standard deviation, but as applied to a sample. So there's a distinct difference there. Let's go back to our sea lion pups. X with a bar, we often just call that X bar, may represent the average weight of a sample of I don't know, 40 sea lion pups that were collected off the north coast of California. Question, can you actually determine the weight of these 40 pups? I sure hope so. Your whole purpose of collecting the sample is to get information from the sample related to your research question. So yes, thus statistics do correspond to a value because they are calculated from a sample, and your purpose of collecting the sample is to collect information from it to learn about the population. And I know you want to see what these sea lions look like, so here we go. We've got a little pup right there, super cute. Aww. Okay. Now I want to ask you a couple questions. I'm going to give you two related scenarios, and you tell me which one is which. The debt of all 2018 HSU graduates versus the debt of all grads that responded to the survey. The top one must be population, and the bottom one must be the sample. All the individuals that apply to your study, but you're not going to be able to have access to every single graduate, most likely, but you will be able to have access to those who responded to your survey. Here is another population, a little goofy one. Maybe you know who these are. These are the wonderful Simpsons. And we've got a little of everyone in here, just about. There's Mrs. Krabappel, there's Nelson, Maud, Ghost of Maud, Mole Man. Okay, so if this is a population, then those who are in this box could be a potential sample. And here's another sample, and here's another one, and here's another one. Now, the idea of sampling, which we'll talk about more in the next video, is to learn about the population. I think we can agree that this sample would be different from this sample. They're different, right? And suppose you were measuring or counting a variable, maybe like height. I know these are fictitious characters, but if you got the average height from sample 1 and sample 2, they would be different. Is the sample mean from this sample wrong? Or is the sample mean from this sample wrong? If they were both representative samples of this population, and we know they're different from each other, is one of them correct and the other incorrect? A big topic that we will unravel over time is that a sample statistic varies across samples, and it's what is called sampling error. And so we'll talk about that in the next session a little bit more, but because that is a really big topic that we will thoroughly discuss throughout the semester. Okie dokie, let's go over an example that brings together the concepts of populations, samples, parameters, statistics, variables, all the things we've gone over so far. So let's look at this example, relaxing after work. The General Social Survey asked a question. After an average workday, about how many hours do you have to relax or pursue activities that you enjoy? To a random sample of 1,155 Americans. The average relaxing time was found to be 1.65 hours. Okay, we're going to identify what was the variable of interest, what was the sample statistic that was determined, the sample, and a population parameter. Okay, so the 1,155 Americans, well, that was the random sample, right? That was a subset of the larger population. So the sample. The number of hours spent relaxing after an average workday. Well, that was what was asked of this survey. That was what they wanted to know, the characteristic of interest. So that's the variable. 1.65 hours. Well, that was a value that was calculated from the sample. Therefore, that must be the sample statistic. Lastly, the average number of hours all Americans spend relaxing after an average workday. Well, all Americans, that is the population that the sample is hopefully representing. And this average number of hours, that is a quantity that would pertain to that population. So that would be the population parameter. Cool. That will conclude this first video. I will create a follow-up video where we will discuss the process of sampling and sampling methods, other properties of variables, and different types of studies. So I will see you in the next video.